Hello guys, welcome back to eBPF programming. In today's video, we are diving into part 7 of our eBPF series, which is also part 3 of our network security journey using eBPF. If you have been following along, you will know we have already explored using XTP and LSM hooks to filter incoming and outgoing packets. Today we are going to take a step further to build a firewall using eBPF and TC hooks to filter IP addresses. So what's the difference between this application and the previous applications? If you ask me, the main difference was the first one we did exclusive for incoming packets, and the second one we did exclusive for outgoing packets, and one was using XTP and the other one was using LSM hooks. And using TC hooks, we are going to build a complete filter both on incoming and outgoing packets. So before going deeper into the code side of that, let me explain what it is a traffic control system is. As the slide says, it's a subsystem in Linux and is very flexible packet processing framework. And that's a small part of the entire network, Linux network stack. And basically it allows us to control the flow of packets into and out of the network interfaces. And the main things comes in this one is queuing, traffic shaping, and packet filtering, and we are going to concentrate more on the packet filtering part, that is using CLS Act. Yeah, of course, the traffic shaping is also important, and that's something beyond the discussion of this one. I highly recommend to read basics of the traffic control system, how it works, especially what this queue is and CLS Act, what are those and how it works. And the key features of the TC or traffic control subsystem is we can put hooks on ingress and egress hooks. It's like basically in other ways is we can put control over the incoming and outgoing packets on an ingress hook where the packets arrive at an interface, network interface, but before they are processed by the IP stack. And this is really helpful for applying filters on the incoming packets based on IP or some other filters. And you can, if you want, you can drop it completely before it's getting processed by other part of the stack. So the egress hook it's just opposite to that. Just before the packets are sent to out of the network. So the stack is created from the application layer or the socket layer. So when it arrives the network interface, we can put a filter there and we can take a decision based on the filter that we use there. And this is useful for applying either for, of course you can control your bandwidth. And we use it for basically for in this application is for filtering packets that leaving the machine. So when we use filters to the eBPF, we can hook into, as I said, both ingress and egress. So incoming to ingress to block or modify incoming traffic, egress to block or modify outgoing traffic. And this is just not only for blocking or dropping packets, but you can manipulate packet. So the possibility of using this one is more than just put a filter based on IP or port to drop the packets or allow the packets. You can do more on that. And these are some important things that you should be familiar with. And these are some basic stuff I collected from using the help of LLMs and Google search. And the interesting fact here is there's a HDB here, HDB. This HDB is not the hack that works, but this hierarchical token bucket. And please read more about this one. It's really interesting. And still, I'm just learning a part of this one eBPF program, because this one has the more control compared to the XTP part. Because XTP was working before the packet was reaching the kernel stack or kernel IP stack or network stack. And eBPF programming was providing a structure for processing those XTP level, but here we have the full packets, so we can do whatever we want based on our logic. And the good part of this one is eBPF program itself is giving us a buffer. It's called skbuff, and that's the actual buffer that has all the packets, data, and metadata. And as I said, we will be using CLS Act. It's a classifier action framework, and TC that allows us eBPF programs to classify or filter packets and decide on the action, that is pass, drop, or mark. Mark is something special. We can have a read on this one. This one is really important, and I'm not covering this mark here, but I'm going to show how we can pass or drop packets based on the filter that we use. So yeah, these are the things that we can think about TC with eBPF. The programmability is the main thing that allows us to write custom logic in eBPF to perform packet filtering or whatever, deep packet inspection. It totally depends upon your need. You can, because we have the full SK buffer with us that has the actual packet with all the metadata, so that helps us to do work more closely on the packets. And these are the some of the commands that help us to create CLS Act and queue disciplines to attach to and create and attach to interfaces. And I don't know whether you have seen my previous videos. In my first video, I have shown the different ways of loading eBPF programs, and I already mentioned on that video that I mentioned the normal ways of loading eBPF programs, and I did omit the part of network program loading. And this is one of the loaders that you can use TC hooks or TC filter to load your eBPF object to a network interface. And you can, by using this command, you can load that, and the eBPF program logic will be working on the network interface based on what you did on the actual eBPF program. So that's the theoretical part about this one. And yeah, when you think about what's the difference between these TC and XDP operates as much lower level and networking stack. So that means we can drop or modify packets very early, and as is shown on the demo, it won't, just because it won't reach the kernel stack, it will be faster on performance base to put filters on incoming packets. Yeah, TC operates a higher level. Actually, it's going to the network stack, actual stack, and we will have more details about the packets and full control over the metadata. Yeah, but in terms of performance, definitely TC might not be that much performance oriented compared to XDP for incoming packets. Yeah, that is all about the theoretical part of this one. And let me check, did I miss something? As I said, in our case, we will be using hooks to attach our eBPF programs to network interfaces and allowing us to filter the traffic based on IP addresses. This is a crucial part of building our firewall that I'm going to show you now. So let us dive deeper into the code part. And this is my firewall. And if you are following from the previous videos, it will be easy for you to understand this, because I'm using the same logic of my previous programs. I create for the other programs we are using only one map, because the first network security program was based on incoming packets, so we just used only one map for blocking the incoming packets, and the other one, LSM hook, was for egress traffic, and there we were using another map for controlling the outgoing packets. Here we are using two maps because we will be going to use two filters. One is for ingress and the other one is for egress. Both is on the same program. So we have two maps, and is type of BPF map hash type, and we'll be filling these maps from the user space application, and there we are adding our IPs for ingress and egress filters. So based on that we will be putting our logic here. See here, if you remember the other XDP application, the struct name was xdp_md. There in that struct we had enough data to process the packets on the incoming packets. Here and the difference is here we are adding a section called TC. The other one, remember, I hope you remember, it was XTP, and this name can be anything. The main thing is this structure, and this structure has all the details as I mentioned, all the packet details. And the same logic, we are just taking the data from the beginning to the end, and we are trying to check the Ethernet header and if there is any issue with the Ethernet header that we are trying to process, we just, and this is another two macros that we use here. One is TC ACT short, and other one is OK. It's just like XTP one that we use for drop and pass, just like here. If it's TC ACT OK means it's pass, just pass the traffic, don't do any action on that. But this means we are just dropping it. We don't allow this to go further to the stack or go for the for the incoming packets. We just block it there on the first part of the network stack itself. For the outgoing packets, when it reaches the network interface from the top layers, we apply this logic there. This is for the difference here you can see is I just put the function names as a different two function names, and this is what we are going to put filter or using the user space application. The logic is same, we just check that map, and if the map has the incoming blocked IP, then it just drops it. And for the egress filter, it is same logic, then a reverse order. Like if it sees the traffic the machine is trying to conduct is on the outgoing filter traffic, so if it matches there, just drops it. And this is the main function that we are making use of. And all these things I have explained on my other videos, like what this one is and what about this constant. And if you haven't seen my previous videos, I highly recommend to go and watch it, and then you will get more clarity on these stuff. And here I haven't used the VM Linux header, because when I tried to use that, I had to redefine a lot of constants and a lot of other functions that I use inside this one that are defined in these header files. So I just made use of the same core eBPF header file. So this is a main eBPF logic. We have two functions. One is for ingress filter and the other one is for egress filter, and the section name we have defined as TC. Those are the main differences compared to the XDP program. So here and here is the XDP. Here is XDP program. See the difference is, main difference is like here we have the XDP MD as a, what to say, the context parameter, and here we have the full SK buffer pointer to that to process our packets. Then this is a user space application, and this is the one that I learned a lot, because this was it was pretty difficult to create this one. It had a lot of errors, and if you search for the help, it is very less help on these stuffs. Basically the same logic that we use here. We create a skeleton file and add the skeleton header here, and up to here is same. Once again, up to here is same, like we just set the memory limit for our app, and we are defining our network interface. This is my network interface of this machine where I'm going to run this application, and we are loading the application from this loader. Open and load function is defined inside the header file of, this is a header file that is this function, and once it's loaded we call this attach hook method. This is an important method here in this one. And if you see the parameter, we are passing the interface, network interface card name, and the filter. This is important. This is a constant that we need to specifically mention here. We have to clearly mention whether it's for ingress or egress traffic. The first one we are attaching for ingress traffic, and you can see I'm attaching my TC ingress filter. That means this program, this application logic here for my ingress traffic. And what it's doing here is I'll learn a ton of stuff here. See, for attaching this one is not a simple operation. We have to create a hook, TC hook first, then we have to create another structure called TC opt. Opt actually is options, opt and s, yeah. And we have to define our hooks properties here, the size and the index, the network interface card, and the attach point, the direction means the constant that we are passing, whether it's for ingress or egress. As I mentioned, this is very important. This is the direction. So once we have defined the hooks, we create the hook using this function, BPF TC hook create. And once the hook is created, we define the options, same as size of the options. And here is another important part, the program file description. This is the one that we passed as third parameter, the one that we mentioned here, TC ingress and egress filter. That means this is the function name of this one, TC ingress filter and egress filter. So using the file description, it is attaching the filter. And this is another thing I learned. Even after using this one, I was getting error that I will show you, but that error was not affecting my application logic. That I don't know. I will show the error. So if somebody sees this who is already know about this TC hooks and eBPF, let me know what that error is. That error is actually showing, when you read it first time, you may feel that is something very big, but when I was searching for that, the suggestion was to mention the flag like BPF TC replace. That means we are replacing any existing hooks on the network interface card for this direction, means ingress or egress. But even after putting this one, I was getting the same error. I will show that. So after creating the options and the actual hook, we attach our hook and options. So when you are attaching, that means we already mentioned our network interface name and the direction and which program needs to be attached. All these are defined here, and we are attaching that. So that's what the attach hook is doing. So using the attach TC hook method, this is a user-defined method I defined here. So using that, I'm attaching both my hooks. See, this is the main differences here. One is ingress and other one is egress. So once after attaching the hooks, the next thing I had to do is I had to define my maps, and as I mentioned earlier, if you follow my videos from the other network security part, you know how to take the maps from the eBPF header file. Actually, the header file that we created is the exact header file from the eBPF object. So everything will be there inside the header file. So we are using this method to get the map file description, and we are using IP in block list, and this one is defined here. Actually, this is the map. We are getting the file description because we need to fill the map. I'm saying map allowed actually is not, should be not allowed, because I copied this same stuff from my other program. It should have been not allowed, in fact, both here. Basically it is for blocking the IP, so it should be not allowed. Let me correct it here. Not allowed. Not allowed. Oh, when I am correcting it here, I have to make it here also, and this one here and here. So once we get that file descriptions, we are filling the map using this function. I mean, using these arrays. One array is for blocking incoming packets, another one is for blocking outgoing packets. I am adding this IP 158 into both incoming and outgoing blockage, and 196 for incoming packet blocking. So I will show that in a demo. You will come to know what exactly it is. So after that, the same logic that we were using on the previous programs, I am just filling the map. Here in this case, I'm filling two maps. That's all the difference. So once that is done, just printing this message. I'm just saying that this filter is loaded into this interface that we mentioned. This interface is actually here. Don't get confused. So after that, yeah, we just wait for key. We are not as this is another major difference. In most of the programs, when you see the demos, you can see that they will indefinitely wait for put these stuffs in a loop, because those programs needs information from the eBPF program, and it needs to be passed to this, and they have to process it here. In that case, you have to wait for wait in a loop, because you may get the notification from the eBPF objects that something happened, and it may fill the map and send the data here and process it. But here we are not doing that, because we are blindly blocking it without taking any other information about this. This is not a recommended method. Just for learning purpose, I'm doing this. Definitely, if you are planning to develop some serious application, you have to use the other method of using some other kind of maps. I already showed a demo of using ring buffer in one of my videos, so you can refer that, how it is differ from this method. So that's it about the code. Now let's the actual demo of how it works. And here it is, and I'm going to just make my files. This will create all the stuffs, and it will load the user space application for me. OC map allowed out. Yeah, it has okay, I think better we have to create that. Where the error is here, we change it here, and it is here, and I didn't change it here. I had to change it here also. This is the map. IPs for not allowed for outgoing, and this one is for the incoming. I think these are the areas that I was using the map. Let me try it again. Make delete. Make clean is best one. Just remove hyphen. I'm just remove all the previous stuffs. Just make eBPF and make skeleton. Now let us try to run it. Yeah, this was the error I was mentioning when I was trying. And this, if you search for this error, you get the solutions to do like replace the existing hook and place your hook. That's what we do in our actual program here. On the attach hook method, I am using actually that. So if somebody is seeing this one and who knows what exactly this issue is, just let me know. But the thing is, actually it doesn't affect my application logic, or it just loads loads my program. And if you search for sudo bpf tool, you can see is loaded my program. One is for the egress filter and other one is for ingress. This is loaded perfectly and the map is there and everything is working fine, but yeah, it is showing this error that I have no idea. I just searched for this one and I really wasted my time on this one because I tried all the solutions and this was most of the solutions are saying about replacing the existing hook. Yeah, programmatically this is a way to replace this as far as I got the information from different resources. So if you know how to remove this error, so let me know that. So let us try exploring this one. So the hook, the ingress hook is for this 96 and outgoing hook is for 158. So let me try ping. So before that, so it should be just to make sure that this one is going to this is another thing I'll mention after this demo. So normally after I'll tell it now itself. Normally after this one we have to clear the hook. So I have to find a way passing the hook's pointer somewhere, and end of this application I have to, after just before the return, I have to clear off all the memories for these hooks. So in that way I can programmatically control, just after ending my application it will automatically delete it. But at this case I'm not doing that because I'm using these structures inside this function. So I had to find a way to use it outside the function and remove it just after this program ends. I mean just before the return. So just because I'm missing that, the filter was still showing there, so I had to use this this shell bash shell script. This is nothing but just removing all the filter that I put for egress and ingress, and I just created the, if there is an existing, is any CLS act is there, I'm just deleting that because all these will be created as a part of my program. So that's about this script. And what I was talking, now there is no filter, and just to say we had an egress filter to 158. 158 is nothing but my another Linux box. Oops, I need sudo privilege to do that. See, we are getting result from here. And just like that, if you I have my Linux here. I think this is on. Maybe I need a new session. 192.168.1.158. So this one has a IP of 158. So here, before the filter, I can reach the IP, and I can try from my machine here. This is this machine has the IP address of 162. So from my 158 machine, I'm just trying to reach 162. See, I can reach it. So now both directions the packet is flowing, like incoming and outgoing is there. So now I will show you what happens when you put the filter. Now I have the filter. Now I'm going to try this 158 again. See, it gets stuck there because it's completely we have filter there, and completely drops off the packets when it sees this is my machine is trying to reach the 158. And what happens if you try from the same machine again? Now I'm trying from 158 to my machine. See, now it's saying no buffer space is available because we are completely dropping off and we are continuously trying it. I should have tried with the number C2 or something like that. And let me try the other one. See, I'm trying it again. Ping to 162 from the 158 machine. So I have another ingress traffic, and that will block this one. See, previously we got the result. Now it is completely blocking my packets. So using this single application, we can put both our ingress and egress traffic. And see, this is a thing I have mentioned already. The kernel error message that is showing here is not affecting my application. So I don't know what exactly that error means. The only solution I got was just replace the existing hook, and I did using this where is that? Yeah, replace macro. So that's how it works, and it's for the same thing. Like for another traffic I put is 96 for only incoming traffic block. So this is my 96 machine. Let me check it. Yeah, it's 96. So if I try to put 192.168.1.162, see, it's not reaching here because I have put an ingress filter on the 96 machine. So that's how it works. Did I miss something? I think I showed everything. Yeah, if I try from my Windows machine that has a IP of 92, yeah, definitely should work. Ping 192.168.1.162. See, it is working because 92 we didn't block. So this is the beauty of TC. Using the traffic control, we can put filter on both sides for ingress and egress traffic. And this is just one of the functions that you can think of. That's something that I can easily show off. But definitely it could be more complicated. Your logic could be more complicated because you have full packet with you with all the metadata, so you can inspect the packet and you can manipulate the packet. Maybe you can think something Think of some pen testing level, creating some malicious packets, sending it over the network. It's totally up to you. How do you design your application? So we have more control over here compared to XDP. XDP is really good for making use of DDoS mitigations. Yeah, but TC is more than an DDoS mitigation. You have more control over the packets. So that's what about this video, and this is how you can build a firewall, your own firewall, using eBPF and TC hooks. I think we have covered a lot today, from TC to the firewall. So if you hadn't seen my previous videos part of this series, I highly recommend to checking them out to get a complete picture of how eBPF can be used for network security, because we already created 2 videos, one for using XDP and the other one is for LSM hooks. On my next video, I will continue exploring more advanced topics in eBPF. I'm planning to move to the container side of this one. Actually, I planned for last week, but something the TC, that is something you should know about. Like, that's why I just shared it here. I hope you like my videos, and if you are interested more on eBPF or something like this, please stay tuned on this channel, and hope I can come up with another interesting topic on eBPF on my next video. Till then, this is a bye from Alphas.